We know that the sun can heat the ground surface to a high temperature. That is why I put these pipes and covered them with a layer of soil a few centimeters thick. So, this is my solar heater, and this is outlet for water which will be heated by the sun. Now we see that the water leaves my solar heater, and the sensor tells us that the sun heated the water to a temperature of 54 degrees Celsius. This is water which has been inside the solar heater for several hours, and it is obvious that the actual heating temperature of moving water will be noticeably lower. Let's look at a similar experiment, but with this cheap reflective film which gives additional solar radiation to my heater. It turned out that the reflective film significantly increased the water heating temperature, and now it is almost 70 degrees Celsius, but it is also not running water. Of course, the heating temperature will be higher if the reflective film is replaced by a glass mirror, and similar effect will be under such walls of stainless steel sheets or under such mirror windows. Perhaps a few tens of square meters of such solar heaters can replace these solar collectors for heating pool water. In addition, their heat with temperatures up to 40 or 50 degrees Celsius may be interesting for industrial processes of some factories or for the initial stage of hot water supply of large buildings. We can notice that this heater is similar to these widely known homemade solar heaters. This version of my solar heater has even more similarities, and it receives solar energy not only through the upper walls of these pipes, but also by heating soil of these gaps. This version has a higher heating temperature than that version, where the pipes were covered with a layer of soil a few centimeters thick. We can verify this fact through this experiment, and this sensor shows the temperature of this water which was inside the pipes for several hours. However, the lifespan of the pipes of this version is significantly reduced due to solar radiation and souls of people who will walk on this ground. Let's study the features of soil heating by the sun, and now I am installing a soil temperature sensor at a depth of 5 centimeters. This is the second sensor, and it is installed above the first sensor, but at a depth of only 2 centimeters below the ground level. Now we see the temperature of the ground in the morning, when the shadow covers it. However, later the shadow leaves the ground, which begins to heat up by the sun. We see that the upper sensor heats up noticeably faster, because it is located at a depth of 2 centimeters, while the lower sensor is 3 centimeters lower than the upper sensor. Now we see that the ground surface has heated up to 50 degrees Celsius, but the soil at a depth of 2 centimeters is 10 degrees colder. At the same time, the soil at a depth of 5 centimeters is 20 degrees colder than on the surface. These facts lead us to the conclusion that each centimeter of increase in the thickness of the soil layer above the pipes reduces the heating temperature by 3 or 5 degrees Celsius. In addition, we saw that the heating rate of the soil was in the range between 5 or 10 degrees per hour. However, in the afternoon the heating rate will be noticeably lower. We see that I installed two sensors at the same depth, which is equal to 3 centimeters. This is the temperature of the ground this morning, but soon this shadow will leave the ground and it will begin to heat up by the sun, and now I show the situation about an hour after the shadow leaves. In addition, we see this mirror which was installed about a minute ago, and this part of solar radiation from the mirror covers the right sensor, but does not cover the left sensor. So, further we will see how the mirror increases the soil temperature, and for example, this is the situation 20 minutes after installing the mirror. Another hour has passed, and it will be interesting to see that the ground surface above the left sensor heated up to about 50 degrees Celsius. At the same time, additional solar radiation from the mirror gives additional 20 degrees of heating the ground surface above the right sensor. We can come to the conclusion that the mirror increases the soil temperature by about 8 degrees Celsius at a depth of 3 centimeters. But the effect will be greater if the depth decreases, because we saw the temperature difference of 20 degrees on the ground surface. Today I also installed two sensors at the same depth of 3 centimeters, but here the soil is wet. Then I covered both sensors to increase the accuracy of the experiment, and I uncovered the sensors a minute ago. We see that the wet ground is almost 2 degrees colder than normal ground, and this is due to evaporation of the moisture and higher thermal conductivity of the wet ground. 20 minutes later, we see the conservation of that temperature difference of 3 degrees, but after that the difference will increase rapidly. So, this experiment shows that our solar heater can have poor efficiency after rain, and the temperature of heating its wet ground will be low. I see the following two causes for poor heating of the wet ground, and firstly, the evaporation of its moisture takes the energy. That is why now we see that surface temperature of the wet soil is only several degrees above the ambient temperature. Secondly, wet soil has a higher thermal conductivity, and this fact increases heat losses down. But on the other hand, the high thermal conductivity improves the heat transfer from wet soil to the pipes of our solar heater. Interestingly, the temperature difference decreases gradually as the wet soil becomes drier. So, our solar heater can be inefficient after rain. In addition, it can be inefficient during partly sunny days or if the sun is low above the horizon, including in winter. That is why I think that 1 square meter of our solar heater will produce several times less heat than 1 square meter of similar solar heaters. But our solar heater is very cheap, and these 25 meters of polyethylene pipe were bought by me for only $4. In addition, we can work here, and therefore I say that our heaters take up no space, and we can quickly and easily build a solar heater with an area of several tens of square meters. However, we see that the soil of my Ukraine is dark, and the soil color of other regions can be lighter, and this will slightly reduce the heater efficiency. But the inhabitants of these regions know that the temperature of their soil is more than that shown by this video due to the high sun and high ambient temperature. Now I remind you how my solar heater looked when it was built, but this is its condition a month and a half later, and now another month has passed. We see that the pipes gradually rise to the ground surface, but we understand that this phenomenon increases the efficiency of the solar heater. Nevertheless, we must periodically add soil on the surface of the pipes, so that their lifespan is not reduced. Here we see grass, which decreases the efficiency of the solar heater, and this is the situation a month later. No grass here thanks to this cheap polyethylene film, which has small holes for rainwater to flow out, and this is the edge of that film. We may think that this pipe installation method is time-consuming. That is why I want to find a simpler method, so that one person can install up to several tens of square meters of the heater per hour. In addition, I plan to measure the efficiency of different types of our heaters to compare them with the efficiency of these well-known solar heaters. We remember that I described them in one of my old videos in the form of these tables and graphs, where we see that they produce up to 20 watts of heat per meter of their pipe.